All right. Yes, myself Rakesh Jain. Yes, 20 plus years with IBM and currently in research AI division in IBM. And I also work in product as well as consulting group. And I'm also involved with the open source activities. I do exist on social media. Okay, talking about engines, and I will go a little more basic than what Jessica and Lisa taught. So, what is an engine? Okay, so there's no animation here. That's fine. So, that's all right. Okay, so traditional engines, right? It's an intelligent system that interacts with some environment, observes the environment, and does some action on them, right? That's basically. When we talk about LLM agents, the intelligence for the agent comes from an LLM. That's basically what it is. Now, you can say that any program which interacts with an LLM can be an agent. Why not, right? To be honest, as of now, there is no formal adopted definition of agents. So we talked a lot of things, and I think Jessica mentioned that you can call anything agent, right? So that's fine. That's what it is right now. But should we really worry about what is agent? In fact, what should be worried about is what is an agentic system, and what it means to be agent. So what it means is that basically there are degrees under which you can go to be more and more agent. And the more you allow an LLM to act on your system, the more agent. So that's basically I think what we should be looking at. And if you look at, I have animation on this.
What are you looking at? You got a question?
Right now you're seeing everything else at once. But what it means basically is that if you take any application, usually an application has some control flow, some component, right? And you can code everything, and that's basically, there's no AI involved, there's no agent. If you go with single call to LLM to decide something, there's some degree of agentness there.
If you need a break or if you need
Right?
some shit,
And
wanting
then you
water or
keep
anything.
going, right? As much as you allow the LLM
Lunch will
to
be served
control
at
your application, then it's more and
10
more
minutes.
agent. A very good example of fully agentic system is if you look up at a paper called Voyager. So that's a implementation of Minecraft, an agent which actually works in the Minecraft environment. Now Minecraft has no rules as such, right? I mean, you have a environment, you build things, you fight, and whatnot, right? And you acquire more and more skills. And that's what that agent actually does. It acquires more and more skills and stores it in its memory, it's in its storage, but it's fully automatic, no human intervention. So that's a very good example of what a fully autonomous agentic system can be. Okay, now before we go further, actually what I'm actually talking about right now is what is the current state of agents or agentic AI and where we are going to. Right? So if you look at a simple question answer kind of scenario, so there are mostly this kind of categories. You can ask simple questions like, by the way, anybody knows how many legs caterpillar has? 16. 6 or 16, debatable. So it's basically something which is the model has knowledge about because it was trained on it, right? It's fact-based. So it's simple prediction. Now, the little more complex question, I have 12 cookies and ate 2 and give some to somebody and blah, blah, right? That's something which goes in reasoning category. Actually, if you think about it, you can easily distract the model. Just add another thing that John had 2 cookies. John has nothing to do with my cookies, right? And the LLM will be distracted. So it's very interesting here. But anyway, so reasoning is another category. And then if you go further, like 58th number in Fibonacci series, right? So that requires some computation. So that's another category. And then the last one is you want to know the current combined market cap of these three companies. That's another, this one requires external knowledge because current information is not inside the model, right? It was taken a few months ago. So in general, these are kind of categories you can think of. Now, what people have been working on is that in order to address all these kind of scenarios, questions, and whatnot, people are coming up with different kinds of prompting techniques. And a very popular one is chain of thought. Basically, you're telling, so LLMs are not very good at reasoning, right? So what you're actually telling LLM is that, look, for any questions you answer, think step by step, and for every step, basically you can output what is your reasoning, and in the end, explain your answer. So that's the basis of chain of thought. Then there are variations of chain of thought, like chain of thought plus self-consistency. This is where you actually tell LLM that, the LLM's output is not the same all the time, right? So this one, you actually ask the same question multiple times and get the majority answer. So it's self-consistency. Then there is self-define, which is basically give feedback to the same LLM using to refine the answer. Another one is program of thought, and this is mostly when you have financial or numerical analysis kind of questions, you would go for program of thought. What it does basically is that instead of dealing with LLM, the language, it actually deals with the code. Because what we have found is that when you are doing numerical analysis, generating code and executing the code and producing the output is more accurate than based on the language only, right? So that's where the program of thought comes in. Then there is reflection. This is similar to refine, but in this case, the feedback is provided by a second LLM. Then you already heard about RAG. Basically, the LLM is referencing an external knowledge source and giving it as a context, using it as a context for its answer. And then similar to that is tool use, which is basically you're going out, again, out of the LLM, and you're doing some function calls to do whatever you're supposed to do. So these are some of the prompting techniques, and last two are basically tools. Now, you may have heard React a lot. That is actually what is driving the whole agentic craziness right now. And React is basically wherever you need reasoning as well as action. Like the last two are actions here, right? So similar to that. So basically reasoning plus calling any tools, that kind of scenario. So that's what React is, and that's the most popular one. So if we go back to this scenario, first one is simple fact-based. It's just simple prediction. The next one, reasoning, you would go for chain of thought. The one where it needs computation, you would go for program of thought. The one where you need, the last two can actually be repeated. Where you need to know text, you have to go outside to get some information, so that's React. And then the last one, actually, the new one I added is more reasoning here, that first of all you have to go get information about those three companies, and then get the information about the fourth company, and then do the computation, right? So this is current state of art, like all the prompting techniques people have done to solve this kind of scenarios. Now this is all prompting, right? And the model teams are also figuring out that, oh, this is how the models are used. Why not incorporate these things inside the model itself? So this is what is happening nowadays, that people who develop the models, they are incorporating scenarios like create or RAG in the model itself. For example, actually many new large language models, they're coming up with inbuilt capability for generation. They use reinforcement learning during the model training or instructioning time. That's where they would do the reasoning, and for every reasoning step, they will have this feedback loop using reinforcement learning, and that's how that improves. So now the reasoning step, which was in agent space before, is now inside the model itself. Now what it means actually is that you don't have to use chain of thought kind of scenarios or prompts when you are using this language models. What it means is that, hey, we learned all about this new prompting techniques. Not relevant anymore if you go start using these new models. But I guess what it explains is that how quickly things are changing, and we have to just keep following what's happening. So that's the model side of things, like what is happening. There's also on the agent side. So we have seen massive support for agents, and just people are crazy creating new agents and doing really, really nice things, right? However, building these agents is not straightforward. You need a lot of information, domain knowledge maybe, as well as sometimes you may have to fine-tune the models as well. So it requires quite a bit of effort from engineers, from researchers as well, right? Now the question is, can we automate all that? I think that's where we should be going. And if you know, for example, AutoML, for example, neural semantic search or neural architecture search. So those are the kind of predecessors where we have seen that how automation actually can be better in delivering something. For example, AutoML gives you the right algorithm to use for your neural network, right? And then the neural network search itself is a really cool tool which actually gives you the best neural networks to use, right? So why can't we do the same for agents? And that's actually what is being happening right now, that LLMs can generate agents. And it's quite fascinating. And imagine, when LLMs generate these autonomous agents, what the world will be. But so where we are right now, there are two categories where we are actually focused on. One is for better prompts, and that's prompting techniques that will continue. The second one, which I find more interesting, is that can LLM learn more components of the agentic system and generate those? For example, not only prompts, but also the tools and the control flow, right? So here are a few papers I found very interesting. Agent Optimizer, that one is used for learning the tools used by the agents. And the last two, agent symbolic learning and ADAS, or automated design of learning systems. This actually do the full thing. They learn prompts, tools, and control flow together. And that's actually quite fascinating, working in this area. So that's somewhat we are also exploring this thing. And basically, we will get to a situation where LLMs can generate agents. And I think that's all I had. Yeah.